Welcome, everybody. For those who don't know me, my name is Serena Tricarico. I work in Edinburgh as HDR UK Scotland manager, but I support the Applied Analytics scientific team. Today, I'm very pleased to introduce Honghan Wu. Honghan is Associate Professor at the Institute of Health Informatics at UCL. He holds a Rutherford Fellowship funded by the MRC and is a Turing Fellow at the Alan Turing Institute. And today he will give us an overview on the development of clinical natural language processing in the UK in the past 15 years. I hope that was okay, Honghan, as introduction. Over to you.
That's superb. Thanks, Serena. Okay. Thanks everyone for joining. As Serena said, this is kind of give people an overview about what happened in terms of clinical natural language processing in the UK in the last 15 years. I'll come to the point why 15 years later. So this is work on behalf of HDR UK funded national NLP project called HDR UK Text Analytics Project. So some people have the consortium over there. So we got a lot of input from people, not just of this particular project consortium, but also people in the community who is doing clinical NLP. I presented some of these partial work to some of these small groups before and got some inputs. We updated the data, got some new results today. Okay, hopefully it kind of make things interesting for you. So a bit of background before going to why we're doing this. So for people who don't know about this HDR UK Text Analytics Project, there's a pointer over there. You can, people interested, you can just click the link or check the link and to see the project, who are involved, what kind of research we're doing, what's the aim of this project. For a very small kind of quick summary, so this consortium trying to stimulate or foster kind of national effort to develop text analytic capability to improve research, hospital service planning, and clinical decision making. So not just for NLP for research, but also somehow we're trying to make NLP technologies useful for health service delivery. And these projects kind of organized in a kind of so-called cross-site mode, which we have about 6 sites across UK. People from all these sites joined together to be a consortium together. And these other people are kind of screenshot of the people's page of this website. I believe many of you know many people here. Just skip this. Okay, so why do we need to do this landscaping? So there's a kind of extraction from one of the aims of this project. So we said we are going to build up an open, inclusive community to bring together siloed and fragmented efforts to explore unstructured health data and survey and map existing UK clinical NLP landscape. That's one of the main objectives of this project. Essentially, what we're trying to say here is a national level collaboration or coordination. But it's something kind of, not something surprising because you might think why we need national coordination. Collaboration, of course, because any discipline we advocate collaboration, right? People do this in kind of self-organized way. Why this is special for clinical NLP then? Why do you need national collaboration? So I think there are 2 main points I try to make here why we not just need collaboration, but also kind of national level coordination. One is the challenges behind clinical NLP just too grand to be solved efficiently by single entities like university, single research group, or a company in an industry, for example. As any NLP, natural language processing tool, in addition to understanding human language itself, is already very challenging. Clinical NLP also has other kind of challenges, The first one I would like to say is this so-called low resource challenge. So as we know, label data is very important for supervised learning. And a big part of NLP, we use label data. And label data in clinical NLP is very expensive. Two main reasons. One, we need experts. The experts are very, very busy, as you all know, and expensive all in terms of time. The time to get access to the data, get things set up in a secure environment is very, very expensive in terms of resource and time. And second point related to low resource, so-called imbalanced data. So by nature, diseases, people with diseases or certain types of diseases compared to the whole population is very small proportion. And which means that data you're going to get is always imbalanced because the things that you're going to look is just a small proportion of the data you get hold of. Especially for many diseases, we look at subtype of diseases, for example, subtypes of stroke. In the majority type of stroke, so ischemic stroke, so 80%. The rest part, two other types of stroke is composed of 20% only. So it's quite small kind of imbalanced data you are dealing with. And imbalanced data is always difficult for any machine learning algorithms. For NLP, is also very challenging. And the low resource also in terms of computing resources. So many of us doing clinical NLP, we know, get reasonable computer resources within the right secure research environment is super hard. Not just because the GPUs we need is expensive, not that, it's more like set up the things needs a lot of efforts, needs a lot of support, which is very, very expensive. The second aspect why clinical NLP is very, very challenging compared to other NLP because of data. In terms of how to get access to the data, you involve information governance. It's there for the right reasons, of course, but for any research to get access to the data is very, very, let's say, not very straightforward. And also, of course, for research purposes, data needs to be de-identified or anonymized, and there's no perfect anonymization tool. You cannot say we can get this data 100% anonymized. You can get it out in do whatever you like for this data. It's not possible because there's no such tool which can 100% anonymize clinical data. And clinical NLP, the final point I try to make, and also I think it's the most important bit compared to other NLP applications, is the clinical domain, medicine domain is very knowledge intensive. Involves a lot of different subdisciplines, including, for example, epidemiology, genetics, pharmacology, and many, many others. And the main difference is you not just pick up things from a free text, you need to make some kind of patient level inference. You look at the signals, you have to make a decision of the signals based on clinical knowledge. For example, you look at a patient with mention of stroke, with mention of bleeding, you could not just say the patient had hemorrhagic stroke, because you have to consider, for example, people might have fall previously, right? So if that's bleeding was caused by the fall and the stroke was not a hemorrhagic stroke, I know this, but not because I'm domain expert. I know this because I worked with the clinicians and they told us actually it's not so straightforward. You get the pictures out, you cannot just make a conclusion straight away. You have to take into the consideration of the domain knowledge, and that's very difficult, not because the knowledge is not there, because the knowledge is not in a computable format. It's hard to get it within your system combined with an NLP component. So for all these reasons, clinical NLP is very, very challenging. You don't want to tackle the same challenging, separately. Same thing to be tackled multiple times. For example, we have very, very few label data, and we always do this within our own trust. It'd be good to have national collaboration, whether we can share resource, share model, share data, share the knowledge, basically. And the second point, in addition to challenges, is clinical NLP is not just for research. You need to interact with health services. Basically, it's kind of a loop, right? Clinical NLP is talk to the EHR system, the data in the hospital. And you also need to talk to service delivery, people doing this service, health service to the patients. And you can see this kind of, bidirectional, which means that you have input from them, you also output to this. And the EHR and the service talk to each other. So all these are conjoined together. We know EHRs, you have different vendors. So your clinical NLP needed to talk to different vendors EHR system. For example, at UCLH, we are using Epic recently in the last 3 years. And guys at St. Thomas also is going to use Epic as well. You don't really want to effort, for example, you talk to the EHR, the interface between the NLP model and the EHR system, you need some kind of, agreement. If you've done once, it'd be good to reuse this kind of stuff. For that reason, you need kind of coordination at national level to avoid wasted effort if some people have done this already. And of course, for health service, NLP talk to the service, and the health service in the UK is a national health service, right, NHS. So it'd be good to do things at a national convenient way. So for all these reasons, I hope I kind of make this point. National coordination for clinical NLP is necessary, particularly in the UK. And that's the motivation. And then for landscaping, what we plan to do there, what we would like to do. So first of all, we like to know who are those people or institutions, organizations doing this clinical NLP. So we need to identify the community. Who are they? How are they connected so far? And also, of course, what they are doing, what their application domain, what kind of tools they are using, what kind of models they're using, what kind of data they are using, all that kind of things we would like to do be more at national level. And also, we would like to know in terms of the timeline, for the past, as I said, 15 years. So what stage have people get on already at this stage for the decades of development, where we are in different fronts. And of course, the most important, once we know all of this, it's very, very important to be a bit more actionable. So what are the gaps? What could we do? What should we do as a kind of national effort to do this clinical NLP, to do this more efficiently? So these are the aims, the goals of the landscaping. So how do we do this method? So usually we do a kind of overview or systematic review. People basically do a search to some database to get all these research papers, then do a systematic review, meta-analysis. That's where usually people do. We wanted to do the same thing like this way, actually, but we found it so challenging to identify those research papers which particularly focus on UK or developed in the UK, for example, working with NHS. Of course, you can do this manually, but it's not very efficient, very time consuming, and you need a lot of effort to do that. So what we decide to do, actually, we think is kind of a good way to do as well. We say we're going to trace the money. So we're going to say, can we get all these projects funded by the founders in the UK, which is involved clinical NLP, at least as one of the main components, or funded by EU or Horizon 2020 or H 2020 recently, involving at least one UK partners. That's why we set to do at the end. So for the founders or for the UK, all this, many of you know, UK now has this kind of UKRI, which integrates all these founders' information all together, and very nicely provide all these APIs to access the research project they supported, and also related metadata. I will show this later. And also we looked at NIHR, National Institute of Health Research, which is not part of UKRI, They don't have API, but they provide CSV files easy for you to analyze. And also I will try to search for other charities like Wellcome Trust, British Heart Foundation, Cancer Research UK for their funded project as well. And for European projects, we go to this website called Cordis, which contains these dumps of their funded projects as well as CSV files. So what we did is we go to these funders, got all this project they funded, of course, using this search combinations, try and find clinical NLP related projects, search for the titles, abstracts. Then for the projects, we're trying to extract related information like persons, PIs, co-Is, researchers, institutions like universities, industry, NHS, and we try to extract outcomes. So this is very good for our analysis. The second part I'm going to show later on. So for UKI, many of you, I think if you submit things to Research Fish, which is a website for you, update your funded project's progress, you're always asked to submit your outcomes in terms of publications and other outcomes like software and tools, talks you gave in the last year, for example. So we got all of this, and for the outcomes, we in this analysis we focus on publications only, papers only. For others like talks, we didn't analyze this in this work. Okay, how do we do the analysis? First, all these things as I just showed in the last slide, things are joined together actually. Funders, funded projects, project involving researchers, projects involving institutions, and researchers associated with institutions. It's by nature, these things are joined together as a nice network or graph, if you like. So what we did is, okay, how about we create a network, a graph of these all kind of types of linked entities? Then the first step. Second step, can we just visualize them using some, easy interactive format? We used JavaScript, using browser user interface to allow user to interact with the network, the graph. I'm going to do a quick demo later on about this. And then we apply these so-called network analysis algorithms. The idea is trying to say whether we can derive insights from this network to identify the community and identify strengths of subgroups and how they can connect to each other, so that we know what are the most important funders, projects, universities, industry, NHS, how they're connected to each other. And for the papers, as I mentioned, what we did a second part of the analysis, which is systematic review and meta-analysis. And basically the two separate parts. The first part gave us the community, how the things join together and the strengths of their connection. The second part is, paper analysis gave us what are the application domains, what kind of technologies people used, what kind of data set they used, and did they publish any open source tools, libraries, models, that kind of stuff. So the results are going to present in these two aspects. So results. Okay, first about the data we collected using the methods I just mentioned. This is collected in February this year. So from UKI, we use these 34 keyword combinations to search for clinical NLP related projects. We got about 107 projects. We did a manual assessment and removed those 36, which are not relevant to clinical NLP. We got about 71 projects. We did the same thing, more or less the same for NIHR, but with fewer keyword combinations, because NIHR fund projects all healthcare related. So we can drop healthcare related keywords. We just focus on NLP. We got about 24 projects, and manual assessment removed 6 not relevant or duplications. We got about 18 projects from NIHR. For European projects, we got a similar process. We found about 5 projects relevant. It's quite a small number compared to UK founders. So we also did for the other charities. Unfortunately, we didn't find any relevant stuff. The reason could be the data they provided. In many cases, it's just title. And for the title, we could not match relevant projects. So we might miss something there, but that's the best we can do given the situation. So at the end, we got about 94 projects, and clinical NLP is part of these key components. That's the core data sets we got. Then for this 94 projects, we did a bit further digging, trying to find interlinked entities, as I mentioned. First, we'll get all this metadata about the project, including title, abstract, dates, budget. For the European project, of course, they're in euro, so we converted using the rate in February time to pounds, from euro to pounds, so that we can do the similar analysis later on. For categories, not every single funders provide all this metadata, of course, but we try to get as much as possible. Then we try to find all these people involved in this project. We got about 139 associate persons as PIs, co-Is, supervisors, students. About 20, I don't remember the exact number. A big proportion of these, not big, a good proportion of these projects are studentships, which support PhD students doing research in NLP, and that's nice to have. I have analysis about this later on. And we also find about 137 organizations, including research universities and NHS organizations and industries as well. In total, 9 founders, and we extracted about 431 publications claimed as research outputs from these 94 projects. And this is all the data we got. First, let's look at this network community evolution in the last 15 years. And why the 15 years? Because the earliest project we can extract from the 94 projects, the earliest is 2007. So that's why it's kind of 15 years in the past. Okay, just an overview about the network itself. This is a snapshot of the network we created for 2012. As you can see, there are different colors here. The blue color are grants, orange ones are organizations. The green ones are people, and the red ones are founders. As you can see, in 2012, there were only 2 projects related, used clinical NLP, and the total amount of money is quite small, about £370,000, involved about 4 organizations. You can see here, actually, it's very clear. And I have to say the data is cumulative. So in the later snapshot, you're going to say, in the later years contains all the information in the previous years, okay? And the size of the organizations indicates the number in terms of total money, pounds they got for clinical NLP projects. The larger, the more money they got, basically. And this is a 2017 snapshot. As you can see, it's much, much bigger. So in total funding strength is about £10 million and 27 grants involved 50 organizations. And this is a snapshot of the most recent data, 2012 February time to last month, basically. So in total, about £41 million and 94 projects, as I mentioned, 137 organizations, and there's a live visualization. I'm going to very quickly show this, just 1 minute. Yeah. You can still see my screen, right? this graph stuff?
Yes, we can, Honghan.
Okay, great, thanks. Okay, so this interactive, you can play with it, zoom in, zoom out. I'm going to share these slides later on so you can get the link and you can play with the data yourself. Just very quickly. So these are data, and as you can see, you see some clear, if you zoom out, some clear clusters here, here, and here. I'll show what these clusters are. But basically, you can zoom in. You can see these red dots are the founders. These ones are the organizations. And this one is UCL. And you can mouse over to see what kind of projects this is. When did it start the project? These are person names and how things join together. For example, you would like to say, you want to see this project involve how many people, and these people involved in what kind of projects, for example. This is myself, actually, by coincidence. I don't know, okay, this is me. Yeah, basically, this is a graph. So visualize this so people can play with it, so that give people some pointers. You can look at the data. You can say what kind of project people are working on and how they are funded and how things are joined together at organization level and project level and funders level. Okay, so just very, sorry, I just unshared my stuff by accident, sorry. Let me share again. Okay, come back to this. Yeah, so this is the current network, 2022. So first thing we'd like to know is what are the key stakeholders of this network? So of course, we like to say the important players from the network, right? To do that, in network analysis, there's a metric called centrality scores. So what we did, we used different centrality analysis metrics, and we did 5, I think, between this degree and all that kind of stuff. We ended up to pick up this one called eigenvector-based centrality. And this, there's a link here. You can just click a link if you want to know a bit more about this. This basically is algorithm trying to measure the influence of a node in a graph, okay? So that's the centrality the metric means. But we did a little bit kind of further definition of a so-called relative centrality score. The idea is simple because we have different types of nodes in the graph, you know, researchers, projects, organizations. We don't really want to mess them up in terms of their scores. So what we did is for the same type of node, we get a relative centrality score. The idea is for the same type, we find a median value of all the nodes, their scores, then to do this relative centrality score so that you know for the same nodes, for example, organizations or researchers, compared with median value, what's the relative influence of that particular node in the network. So the analysis later on based on this RCS, relative centrality score. First, for the founders, for the nodes of founders, we got this table. The central column here is basically this, relative centrality score. It's ordered by the score. You can see MRC and EPSRC are the most influential founders for clinical NLP, even though H2020, the European funded projects, got the maximum amount of funding. But in terms of network-based influence, MRC and SPSS are most influential. Okay, you can see this kind of, you know, order list. And just, you know, I have these small boxes actually gives us this kind of key messages. Okay, so the key message here is MRC PRC plays a critical roles, which is about, you know, more than 3.36 or 3.34 times more influential compared to H2020, which has the highest funding strength and the medium central score in all funders. And this for organizations. So you can see here as listed universities. The top 10, I didn't list it just for university, I list organizations, including NHS and the industry, but the top 10 are only universities. As you can see, Manchester University is the highest influential, and followed by UCL and Cambridge, Edinburgh, while Edinburgh got the most funding in all these projects combined, 6.3 million pounds in total. And this is a top NHS organizations. As you can see, Salford, which is a trust near Manchester, is the most influential in terms of NHS organizations, followed by Glasgow, UCLH. While SLAM, even though the centralized score is not very high, but as you see later, a lot of studies are using their data actually in terms of EHR. The top 5 industry organizations, this is a list, Uptrace, Factor Matter, Medallion. So these are all industry partners funded by the founders. It's good to see, look at these relative centrality score, they are all higher than 1, which means that industry organizations are now playing kind of influential roles now in the community, which is a good thing for the community because they're taken up by industry, basically indicates the technology is kind of mature level getting much higher compared to previous years. So kind of, quick summary about the findings of the stakeholder kind of analysis. The dominant influence of all these organizations are still universities, as I have shown you in the first table. All the top 10 are universities, which might mean that the field is still research-dominated area in the UK. But there are very promising signs that NLP technologies are starting to be taken up by the industry and health service providers. And these are very, very good signs. And for individuals, for people, for persons, I didn't, show the result at the person level, but kind of summary about the distribution in terms of their scores using a histogram. So x-axis basically is the relative centrality score. The y-axis is the log scale, the number of people with that score. So the highest score is from one person. I'm not going to show the person's name. Is this score, very, very high. And the second highest is 0.072. And there are 3, followed by 3 people in this range, but majority of these individuals are less than 0.05 centrality score. So it's kind of, imbalanced, and long tail kind of distribution, as you can see here. Okay, for the trends in terms of the money across different sectors in the last 50 years, I split this into 5 periods from 2007 to 2010, 3 years group. So you can see this. So in total, you can see this kind of very steady increase along the years for the total amount of money, which is very good, which means the investment from the government, from the different funders and charities are increasing. And also the amount involved NHS increased, particularly in the last 3 years, a very big increasement. And also for the industry, the amount also a huge jump in the last 3 years. These are all very good signs, in my opinion. So particularly the industry involvement in all projects has leaped from less than 1 in 15 in this year period to 1 in 1.5, basically 10 times in the last 3 years period. This indicating a possible increased technology maturity of clinical NLP in the last 3 years. So we also did this connectivity analysis, trying to figure out the key subgroups and how they connect to each other. So as you can see, as I mentioned previously in the live demo, we do see some small clusters in the whole graph. The first one would be this one in the top left side. This is a funded project that people funded by NIHR actually. So NIHR, as many of you know, usually funds translational research. So which means that this project here, a bit more translation, which means that project is supposed to be delivered in a healthcare service environment. So this cluster here, Innovate UK, which are those funds companies doing kind of, at least proof of concept for the industry to do products. They produce products. And this cluster at the top right corner, those European collaborations, funded by European Union. So the majority part of this network, of course, are all other funders, MRC, PSRC, BBSRC, for example. Those are research projects. So as you can see, some of the connections are quite weak. Only one link over here and over there, maybe 2 links or 1 link. So they form kind of natural clusters, not very well connected between these clusters. So to quantify how well they connect to each other, so I did this called K-H connect graph. You don't have to know what that means mathematically. Essentially, K is a number, the higher means their connections are stronger, okay? So analysis K-H connect graph, as you can see here, first, a good thing, everything joined together. So K equals 1, which everything joined together. That's good. But when K goes to 2, some clusters separate from the main cluster, like Innovate UK, Horizon 2020 funded projects, which means that they are very weakly connected to the core network. But when the K increases, some founders dropped out, some funded projects dropped out. For example, go to 5, we dropped out the ESRC, you dropped out the BBSRC. When it goes to 6, ESRC is dropped. When you go to 9, we only got EPSRC, MRC, the core network left. So this basically quantifies how things join together. So what does that mean? That means that Innovate UK and its funded projects are very weakly linked with other funders, their funded project people. So only 2 edges to be very specific. And also this analysis also shows a pretty strong connectivity among research projects funded by MRC and APRC. As you can see here, it's about 16 is the maximum K value they can do in this analysis. So pretty strong. You might be interested in knowing, what kind of core network this is. So I did this 6H connected component from the graph. As you can see here, the grants, the funders, organizations, and 1 person here form this core network of clinical NLP. Okay, just look back 2 years. As you can see here, if it is a snapshot, 2 years ago, H2020 and Innovate UK is not connected to this core network at all. So the connection was created in the last 2 years, basically. So this is what these analysis tells us. But still very weak, but it's a good sign that things going to join together now in the last 2 years. Then we're also interested in the training for next generation clinical NLP leaders. So we look at the studentship projects. As you can see here, different snapshots. The first project comes out September 2016. It's funded to University of Edinburgh. I believe I know this person, there's a supervisor behind this. It's based in the Asher Institute, I believe. And 1 year later, we got 2 more projects. One is from Birmingham. I think we know these people over there as well, and some other projects. And in 2019, got 8 projects. In 2021, last year, October time, we got 16 projects. So there's a lot of projects came out in just a few years back. So this tells us, since 2016, studentship projects has increased from just 1 to 16 across 14 institutions. I believe this was a big boosted by the CDT programs across the UK, AI in CDT in healthcare. Those are very, very helpful for clinical NLP. The patterns of continuous increase and widespreading are very encouraging indeed. Okay, last, a few slides about the systematic review result on the research papers focus on applications, technologies, all that kind of stuff. So as I mentioned, we did this systematic review, and we have 5 people, their names listed on the final slide for acknowledgement. So we did this title abstract screening. We got about 159 papers relevant. We did a full screening and found 107 papers indeed relevant. Then we did data extraction for these aspects, including data sets. We really want to know what kind of data they are using for clinical NLP. We're interested in what kind of EHR, what kind of other data publicly available like literature or social media they're using. We're interested to know the health categories, focus on what kind of disease areas they worked on. We're interested in the NLP technologies like machine learning, deep learning, or rule-based, that kind of stuff. We're also interested in application categories. I will show what we mean by that later on. As I mentioned, knowledge intensive is one of the features of clinical NLP. So we are interested in knowledge representation technologies behind all these research papers. We would like to know what kind of applications has been deployed in real world settings. Out of these 107, how many models have been deployed in NHS, for example? We also want to know whether they have done any external validation or what kind of international collaboration have been done. But for the final 2 aspects, I haven't provided results because of the space. So the figure here shows the overall pattern of the papers along the years. As you can see, it's always a steady increasement in the last 15 years of the research papers in clinical NLP in the UK. The first analysis is about health categories and disease specification. So the y-axis gives you the different types of disease, health categories is the definition of this based from this website. So as you can see, apart from the other, I'll show details about other later on. Most study were mental health, and then followed by treatments, different types of treatments. As a majority of these are drugs, pharmacology stuff, and oncology, cancer-related stuff, and CVD, and cardiovascular diseases, infectious. COVID-19, there's 1 or 2 papers over there. And for the others, we look at this disease specification of the others. As you can see, a majority part of that so-called general applicability basically means that not for particular disease, but a general tool for any potential use in healthcare, in the hospital, for example. So it's not for particular application domain, but it's a general tool, basically. And for others, basically, a bit kind of spread in different categories, including adverse events, infection disease, protein study, and all that kind of stuff. So very, very diverse, basically. And for application domain, we look at definitions, which is defined in this paper, which is linked here. So the majority part is called disease information classification, which look at classifying diseases. It's about 45%. Second category is called language discovery and knowledge. It's looking for extract knowledge or information from the free text combined with ontologies. The third bit is called diagnostic surveillance. It's about 17%, extracting disease information for patient for disease surveillance. And about 9% cohort epidemiology is creating cohort for research purpose. And finally, about 8% is technical NLP, just particularly focus on understanding language itself. And look at, we know for NLP, there are different types of tasks. For example, named entity recognition is trying to identify named entities like diseases, drugs, all that kind of stuff from the free text. And text classification, basically giving a text, whether you can make the classification like whether the patient belongs to a certain type of disease, for example, or relation extraction. So all these different types of NLP tasks, as you can see, most of them are focused on named entity recognition and text classification, followed by a relation extraction. Things like, drug use related to adverse events associated with the drug use, for example. And if you put this to two-dimensional space, the X to be the NLP task category, the Y to be the health category, you can see these, scatter plot. The size of the dots here indicates the number of papers. So you can see these bigger things like, text classification used a lot for disease information classification, and named entity recognition used also a lot for this disease classification, but also knowledge extraction from the free text, right? You need to extract mentions of particular things, and named entity recognition, of course, is the right way to do. And very interesting, look at the small stuffs like this one. It's called natural language generation, which is very small but very exciting new development. Generate text automatically, like discharge summaries from the hospital data. That's very very good. So not just look at the big part, but also look at the small circles. It's also very, very informative. Like for this one, temporal extraction, very important, but very challenging, of course. And for NLP technologies, we look at machine learning based, deep learning based, rule based, and others. A majority of these using machine learning based approach, and deep learning is increasing in the last years. Rule based is still a big part of this methodology. And if you look at machine learning based algorithms, you can see these different technology used. The majority of them using SVM, and others basically they didn't specify what kind of methods over there, and followed by Bayes or its variants of models using Bayes theory, and logistic regression random forests used a lot as well. And for deep learning, CNN is the most used technology, and RN and LSTM used. These overlaps between them, so used a lot as well. Transformers, there's only 2 paper use this, but increasingly in the last years. And also put this in the year timeline. So as you can see, the gray bar or kind of black bar is increasingly from 2016 to last year's, which are deep learning methods, particularly because of BERT models. Transformer comes out at this time, so got a hype from the last year's. And I guess for 2021, we haven't, because of the data we collected, it might come up when we refresh the data later on. And very interestingly, if you look at rule-based approach, still a very big proportion of that, even in the recent years. The reason could be, for clinical NLP, people always trying to know why, how it works, make it more explainable, and that's why rule-based approaches still play a very important role. That's the unique part of clinical NLP compared to other NLP domain. And for knowledge representation, a lot of them are using ontologies. And the next big part is pre-trained embedding models, followed by customer dictionary and BERT models and others. So for the pre-trained embeddings, the different types of embeddings, of course, and from different sources. I just list the most, top many, maybe top 20 or something papers. You mentioned these kind of different types of embeddings they use. For ontologies, the most used ones are UMS, Unified Medical Language System, which itself actually is a mapping between different ontologies. Then followed by SNOMED-CT and mesh term, and CAPI is a chemistry ontology and protein ontology over there. These are mostly for drug-related studies. Dataset. So very particularly, we're very interested to know what kind of data set people worked on. Turns out literature, research papers are the most used data set, about 54%, and followed by EHR about 29%. If we break down this to the types of EHR people worked on, as I mentioned, a majority part is from Sutherland Moseley CRIS data set, UK based. For public data sets, only US based data sets are publicly available, mainly from MEMIC. Some of these I2B2 and N2C2 benchmarking data sets, some of these using MEMIC as well. So MEMIC is basically the only data set, comprehensive data set people can get use of, which is not from the UK. So this is a big gap for NLP in the UK. So for open source, a majority of these are not open source, not provided. And similarly for model, not just the code, but the model. Okay. Deployment. 90%, 91% never deployed in NHS. Very small number is tested, deployed in NHS. Out of these, nearly 4% is for 5%. I break this down to health categories. Majority of these for treatments, and this for others, basically general, not just particular disease area. There's about 20% for COVID-19 related stuff. COVID actually moved things forward a bit faster compared to previously. That's the conclusion here. Okay, so given the time, I have to summarize what we did, what we found. So basically we found this community, these are numbers, and what the community are doing, where we were. Basically, NLP involved very, very fast in the last 15 years, have achieved a significant in terms of numbers and maturity level. And also for the next generation researchers, there's a big steady increasements as well. All these are good signs. And NLP tasks mainly focus on NER and text classification, and technologies and deep learning is increasing very, very fastly in the last 3 years. Rule-based are still very popular. The gaps, including the landscape is still research dominated. We really want to see more NHS, more industry partners to be involved. Connections are weak between this research industry and NHS. EHR data are one of the major gaps, very small proportion used in the UK EHRs, only mainly from 1 or 2, up to 3 EHRs, Sutherland Moseley, King's College Hospital, Oxford, potentially, Islington as well. Very few deployed, very few studies deployed in NHS. We'd like to see more to be deployed testing in NHS. And the code sharing and model sharing is a big gap over there. And that's it. And that's acknowledgement. Thank the founders, thank these people, help us do all these data extractions. Very time consuming.
Thank you very much, Honghan. I'm conscious that we have only 3 minutes left. So,
Yeah.
But thank you, it was very, very, very good. We have a question from Emily. She is a lay member of our community, and she wants to know whether the NLP data are standardized and reliable, free from major biases, therefore good enough to work with at national level. Can you elucidate that?
Yeah, that's a very, very good question. I would say, like any data sets, there's always a bias with the kind of free text data as well. But I think combining free text data with structured data, there's a potential to make to tackle this bias issue better. That's my quick response to this, because the free text data is much richer. Many things you coded is problematic. There's bias in the coding itself as well. So what I'm trying to say with free text, I hope we can address this better, but of course we cannot eliminate bias at all. I hope this makes sense, Emily.
Nodding. Emily's nodding, so she's happy with your answer.
Well, thank you very much. I'm sorry my question was rather basic because I think from layperson, while they're interested, I think there's a huge knowledge gap in trying to understand this. I guess people's anxiety is much less over time. I think in the beginning they were getting a bit worried about the use of their data recorded, say, by GPs, and they might well be concerned about privacy, being re-identified, that sort of thing. But I hope messages are sent out to allay them, because I really would like more people to be more relaxed. And I think this is where the assurances, if they could be more upfront and publicized, that would be helpful.
That's a very good point. I think, I'm not sure Natalie's here. Natalie actually is organizing some events involving these lay members and public patient involvement, particularly for these using the data for research, their opinions from different, public audiences. Yeah. Yeah,
because I feel that sometimes you might just be getting all the input feedback from middle-class white women. Is what I fear, that people who are different and from poorer areas, they're not represented. Whether that's a concern you have, that you might not quite, the researchers may not be focusing on health inequality, for example.
Yeah, that's a very, very, very valid point. Yes, I agree. Yeah, as I said, compared to structured, I hope free text can, at least different aspects, we are all biased, but hopefully combine them together, we can be less biased. Yeah.
Well, thank you very much for a very interesting session.
Thank you very much, Honghan. Thanks everybody for joining. The next seminar is on the 12th of April. And Eleonora will present on developing and deploying AI in the NHS. So please join us. Good evening to everybody.
Thanks.
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 See you. Bye-bye.
Bye.